Hi there, and welcome to this EduConnect video on circles. So the first thing I'm going to look at is the three key terms in relation to lengths of circles. These are the circumference, diameter, and radius. So the circumference refers to the length around a circle, otherwise known as the perimeter, for other shapes. Now in a circle it's very important that you call it the circumference and not the perimeter. Next is the diameter. So the diameter is referred to as the distance across the center of a circle. So essentially it connects 2 points in the circumference and it must pass through the center of the circle, which in this image here is represented by the big black dot in the middle there. Now the radius is a length from the center of the circle to the circumference. So it doesn't pass through, it just starts at the center. Now this is the length of a radius is half of that of a diameter. Now we're going to look at some more terminology related to circles. So the first thing is a chord. Now a chord is defined as a line interval that connects 2 points on the circumference. So an example of a chord would be the diameter, because it does connect 2 points on the circumference. This chord over here is also a chord, because as well it connects these 2 points on the circumference. Now the area made by a chord, so this little area here, is called a segment. So always remember that the area made by a chord is a segment. The bigger part here is also a segment, so everything that's like on the other side of the chord. So the smaller segment is called the minor segment, and the bigger segment is called the major segment. Now the next terminology is the tangent. So the tangent is any line that only hits the circumference at 1 point. Now, very important to note here is that the point at which it hits the circumference is at a right angle to the radius. So as you can see here, this is a radius because it goes from the center to the circumference. And this is the tangent, this is the point at which they hit, and as you can see, it's a right angle. And my computer's dead. Okay. Now, next up is the sector. So as you can see, there are 2 radii here. So the plural for radius is the radii, double I. So a sector is essentially a part of a circle that is enclosed by 2 radii, right? Now this has a similar sort of thing to the segment. So this bit here is called the minor sector, and everything outside of it is called the major sector. Now it's the moment you've all been waiting for, pi. Hooray. So the first thing we're going to look at when we think about pi is some terminology for everything we learned already. So the first thing we need to know is r. So r is equal to the radius, right? D is the diameter, and c is the circumference. Now, what is pi? So essentially pi is this symbol right here that you can see on this beautiful meme. So all you have to do if you want to draw it out is do a line and then 2 lines like that. Alright? Now, you may have learnt in primary school that pi is equal to 22/7. I'm here to tell you that that is incorrect. I know, it's mind-blowing. Now the reason is because pi is an irrational number. So what's meant by an irrational number is that it cannot be a fraction. So instead, what pi is 3.14 and some other stuff that you don't really need to know. You only need to know it to 2 decimal places. Now, how do we work out pi? So if you're in an exam, they're probably never going to ask you to work out pi, but just for the sake of it, I'll teach you what it is. So pi is essentially equal to the circumference of a circle over the diameter, right? Now, if you look at any circle, this will hold true. Now, this is also the formation of one of our key formulas. So to work out the circumference, it's equal to pi times d, and we know that the diameter is 2 times the radius, so it becomes 2 pi r, right? Now, you should all know how to do this based on the algebra that you guys have learnt. So all I did was I multiplied both sides by d to get pi d and c, and then I flipped them on because it makes it look nicer. So I got c equals pi d. Okay, now the next one is to find the area. So in geometry, the area is noted as a capital A. So the area is equal to pi r squared. Now, to find pi in an exam, you're allowed calculators in high school. So to find pi in an exam, don't just multiply by 2217. Always find the button on the calculator. So on my calculator, it's above the times 10 to the power of x symbol at the bottom of the calculator. Mine's a Casio calculator. So pi is very fun, and I hope you have fun with it. Now the next thing we're going to look at is arc length and perimeter of sectors in composite figures. So the arc length of a figure is denoted by this fancy L over here. So essentially, an arc is a portion of the circumference. So in this image over here, you can see that the arc length is here, and it's part of this little sector by these two radii. Now, as you can see here, you can see this weird looking thing called like that. Now that's called theta. It's a Greek alphabet. You'll notice in maths we use a lot of Greek alphabets in geometry and lots of other things. So we use things like alpha, beta, theta, and then later on you'll use delta and things like that. So theta usually denotes any angle. So when you get into trigonometry in year 9, you'll also see things like sine theta and cos theta and things like that. So when we're looking at arc length, what you have to do is the formula is essentially theta on 360. So that essentially finds you the fraction of the total circumference that you need, because the total angle at the center is 360 degrees because it's a circle. So theta on 360 shows the amount of the fraction that you need, the amount of the circle that you need. So then you multiply that by the formula of the circumference, which we worked out was 2 pi r. So that's what L equals. So that's to find the arc length. Now to find the perimeter of the sector, so we've already found this length over here. Now all you have to do to find the perimeter is just add these two r's. So always remember that. So if you want to find the perimeter, which is denoted by a big P, you get theta over 360 times 2 pi r plus 2r. Now, another thing is the thing called exact values, right? So, pi, as we all know, is an irrational number, so you can't just leave it as a fraction, because you can't make it into a fraction. If you leave it as 22 over 7, you will lose marks. So, what you have to do is say that theta is, let's say 200. So essentially what you get, let me just go down a bit. So you get, if you want the arc length of, say, theta equals 200, and say r equals 20. Okay, so L equals 200 on 360 times 2 pi. Now we should all know this from our substitutions. You make a bracket, 20, right? Now this is equal to 200 on 360 multiplied by 2 times 20 is 40. So that's there's two coefficients. So it becomes 40 pi on 1. That's the same thing. Now with multiplication of fractions, you can cancel things. So here you go, 200 and 360 can cancel the zeros. You can make that a 10 and that a 9. And that's about everything you can cancel. So then you multiply the top, you get 20 times 10 is 200 pi, and on the bottom you have a 9. So if you say you've forgotten a calculator, it tells you to leave it in exact value. So this is in exact value, because you don't round anything. So whenever a question tells you to leave it in exact value, always leave it like this, with a pi. Don't multiply it by pi. Now the next formula is for the area. So the area is essentially the same thing, but you just get rid of instead of the 2 pi r, you make it into pi r squared. So the area of a sector is theta on 360 multiplied by pi r squared. And in this instance, you don't need to add any r's because it's just the area. Now, the next thing is composite shapes. So what I've done here is drawn up a composite shape. So let's say that this is, let's say it's 10, and this is 20. Now, what I want you to do is I want you to try and work out, and this is a rectangle, I want you to try and work out the perimeter of the entire shape first. So go and have a look at that. So what you should have done is first, we all know how to find the perimeter of a rectangle. So this is going to be 10 as well. The other side's going to be 10 as well because it's the perimeter, because it's a rectangle. So it's 10 plus 20 plus 10, which is equal to 40. So the perimeter of the rectangle is 40. Now remember, we don't need this bottom side because that's part of the shape. It's inside the shape, so it's not part of the perimeter. Now this arc length, this over here is actually an arc length. And we know that this angle over here is 90 degrees. So if we use our formula, we can get 90 on 360 multiplied by 2 pi r. Now, what is r? So now, as we know, the radius is the same around the circle. So if we know that this is a circle, this bottom bit here, we know that the two sides here must be equal, right? And it's a sector. Just remember that. Keep trying to practice things as you see circles. Try and work out which one's sectors and segments. It'll really get in your head then. Now, as this is a rectangle, we know that this side over here is 20, right? By virtue of being a circle, this has to also be 20, which means the radius is 20. So that is then equal to 90 on 360 times 2 pi 20. You can simplify this now. So 90 on 360, you can cancel the zeros. And 9 on 36, so there's four 9s in 36. So you cancel the 9 and make that a 4. So that becomes 1 on 4 times 40 pi on 1. Cancel again, so that's 10, and that's 1. Right? So then that's 10 pi. As exact values. Now, if you use a calculator, you should get if you use a calculator, you should get 31.42 to 2 decimal places. Right? So now, if you want, you can go and find the area. So to find the area of the rectangle, very simple. Just 10 times 20, which is 200. Also, I made a mistake here. So for the perimeter, in this, in such an instance where it doesn't have centimeters or meters in the lengths, always put a U for units at the end. If you don't do that, very often teachers can take marks off you. So the area of the rectangle would be 200 units squared. Now the area of the sector, as we know, is theta on 360 times pi r squared. So we know what theta on 360 is. We already worked it out. It's 1 on 4 multiplied by pi. R is 20 squared, which is equal to 1 on 4 times, now 20 squared is 400, so 400 pi on 1, which is equal to 100 pi. Now that should have gotten you something around 314. Well, that brings this video to an end, and I'd like to thank you all for watching this video. Please feel free to like and subscribe, and also comment any questions you may have. If you have any further questions or doubts that you'd like clearing up, please feel free to go onto the EduConnect website, which will be linked in the description, and sign up for one of our free plans, where I'll help you by using video calls to clear up any doubts you may have.